Okay. Oh, need to hurry. Um, I need you to be aware of the variable E, right? Euler's number, not Euler's constant. It's Euler's number because Euler actually has two numbers attributed to himself. So he was a brilliant mathematician. He came up with Euler's constant and Euler's number. Well, somebody else called it after him, right? But you need to know the letter E, and it's used in many areas involving exponential growth and exponential decays. I'm not going to go into why and how this number came up. If you want to research that, you go for it. But it is similar to pi. It's irrational, right? It's an irrational number, and the number is 2.71828, and it never ends. Just like pi, it doesn't end. It never ends. Euler's number is used in everything from explaining exponential growth to radioactive decay, right? Explaining. So if you want to look it up, you go for it. It's also used in finance because finance obviously want that exponential growth. Don't confuse Euler's number with Euler's constant. You know what? You actually don't have to worry about it. I won't trick you on that, but I just thought I'd put that in there because his constant is this. But it's not on our calculator, so we won't have to worry about it. This is what I need you to remember. Therefore, you may see an exponential equation that looks like this, right? And to access it, you just press second natural log to access E. Let's do that real quick. Go to your home screen, and if you press second, and you see this, you're going to need this in this unit, guys. Log, you see log, and then under log, we call it natural log, ln. So, but if you press second and ln, it calls e to the something, right? If you put e to the 1, to the power of 1, it's going to actually give you what that number is. Not the whole thing, but it's going to give you the first couple of digits, okay? But quite often, e is going to be there, so don't panic. It's just Euler's constant, and we have actually a button that allows you to access that. Okay, furthermore, doubling period, the amount of time for money or population to double applies to increasing functions. That's very important. Doubling time, increasing functions. So, example, right? If a certain population of, let's say, 1,000 people has, write this down, has a doubling time of, let's say, 10 years, right? It means the following. So we have time and population. It means that at time 0, how many people do you have? 1,000, correct? And what happens after 10 years? What's going to happen to the population? It's going to double. So you're going to have 2,000. Another 10 years go by. So we would be at time 20, right? What happens to that population that you had before? You have more people now, but they double again. So that would turn into 4,000. And that process would continue indefinitely, right? So after every 10 years, watch this, on this side, we're just going to go plus 10, plus, not times, plus 10, plus 10, okay? And so we're going to come up with a table and actually be able to use regressions to come up with the equation, okay? Here, half-life times time it takes for a population to reduce in half, right? Time for population to reduce in half. of the initial. This is obviously a decreasing situation. Several questions call it decay, right? Something is decaying, that's hint hint for it's decreasing, okay? And so example, right? Initial dollar amount, let's say it's $10,000, right? Half-life is 3 years, let's say. Every 3 years, you're withdrawing money from this. Let's say you're retiring and you're withdrawing money from your account. And so you would go time, and in this case, money. Time is always your independent, guys, okay? Time is independent. So at time 0, you have 10 grand in your bank account. 3 years go by, you will be down to half of that. That's what half-life is. After another 3 years go by, you're going to be down to half again. So that's 2,500. Okay. And this actually keeps going indefinitely, but 3 suffice. 3 will be enough. Okay. Okay. Page 8. So that's the difference between half-life and doubling. So when that happens, we can actually conclude this. Let's do a word problem. I don't know if you actually took the time to try one, but let's go ahead and go to page 9 here. I asked you to do this page, but if you didn't, here it is. Did I make a video and post it, or just the key? I think it was just the key scanned, right? So I'm going to walk through it because it's important. So there's a population of bees, and we know that the initial, right, A is 1,500 bees, right? That's the initial population. Put that in quotation marks like that. Is the population increasing or decreasing? You look at the bracket, right? Increasing, explain. Given y is equal to ab to the x, right? B, if b is greater than 1, it's increasing. Okay? So b is equal to 1.15, therefore increasing. So if you need to explain, just go a little further, right? And go for it. What is the rate of increase or decrease? There's a rate of increase stated as a percentage. That would be, rate would actually be 1.15 minus 1, which is 0.15, or 15%. So don't round this. If it had 4 decimals, keep it as 4 decimals. Don't round it. Use as is. Okay. Increase. And what are we in? Let's just look at what time represents up here. Time in years per year. How long will it take for the bee population to double? We can figure out the doubling time, right? Initial population, just go by what it used to be. It's 1,500. Okay. So doubling would be 3,000 bees, right? So therefore, we're going to do this. Y2 is equal to 3,000, and we're going to go ahead and find the time it takes to double. By the way, ladies and gentlemen, once you find this, that doubling time never changes. Like you've now determined what it is. So let's go ahead and do that. I'm going to actually enter this into my calculator, and the nuance here is getting your window right. I'm already going to go 3,000 for my Y2. I'm going to enter that equation. So before we leave, we're going to make sure we know this, okay? How to do the doubling and what does it mean. My window, I'm going to go 50 here. I know my Y max needs to be way greater than that because it's increasing. There it is. And there's my 3,000 line. Why am I picking 3,000, guys? Because it's double the initial, right? So if the initial had been 100, my doubling time I would have to use 200 as my y value, right? So just go by whatever the initial population is. So we go 4.959. That keeps going 3,000. And what would you say? This actually rounds to 5, right? 5 3,000. So doubling time is 5 years. So what does this mean? That every 5 years, you need to know this, every 5 years, population doubles. So another 5 years go by, what will your population be? 6,000. Another 5 years go by, 12,000, right? You double based on the previous amount. Because you have more bees, they're going to produce, right? There is going to be a limit because the beehive can only support so many. So we're going to talk about that next. How long will it take to reach a population of this? No problem, right? We know the population. We're going to go second, trace 5 before we go. And if the bell goes, but I still have time, there are pages right after this that deal with word problems, and that's what I'm going to assign. Okay. Is my window good for this? No, it's not good. So I'm going to go 10,000 for my Y max. And then I'm going to change that to 9,250. There it is. So second trace 5. Just hit enter. That's 13.02. 13.02, 9250, right? It takes 13.02 years. If I asked you years and months, what would you do? Take 13 away from this, multiply that by 12, right? And then round it to the nearest month. How many bees after 60 months? I'm tricking you here, right? Remember, time is in years. It's years, bees. That's what our time is. So watch out, right? This would be the equivalent of 60 divided by 12, which is 5 years, right? We actually know that because we just figured it out here. I shouldn't have used 60. I should have used 72. But you would go second, trace 5, x is, sorry, second trace value. Why is he rushing? Because the time is about to go, okay? Y is equal to, I'm just going to go by it actually says 3,017 Bs. But Mr. Dirksen, you said we rounded the time up there, right? So that's okay. And then this is another one, last one, probably most important one of all. If the capacity of the beehive is 15,000, determine the domain and range. So I'm going to go ahead and find that point first of all. 15,000. Second, trace 5. I need to change my window, but here it is anyways. So this is 16.48 years to get to the 15,000 mark. Hang in there, we're almost done. So that means that my domain, when it comes to time, goes from 0 to 16.48. My range is going to go from 0, what was my initial population? We had 1,500 bees, right? And we make it all the way to 15,000 bees. So your graph kind of looks like this, and it stops up here. It starts here, right, with 0, 1,500. Sorry, it was like a run through. One more thing. If it asks you for half-life, what's the half-life? You can't have a doubling time and a half-life. You can't have that. If it's increasing, we're talking doubling time. If this is a question that involves half-life, you do the opposite, right? You say, hey, I started with 1,500. How long is it going to take me to get to half of that? So 750, right? And then you would find the half-life the same way. It's just different approach. So homework, starting on page 12. I gave you lots of room, guys. Lots of room to do the work. And I will post the key for that. There's very weird looking ones. Just type it in exactly the way you see it. So it goes all the way to 19. So no textbook, just this part here, okay? Thank you guys.